Hi everyone and welcome to Autodesk PowerMill. So as you know that we have already completed all the modules, and these modules included the introduction to PowerMill, and then we have discussed about the 2D toolpaths and machining strategies. Then we have completed the 3D toolpaths and machining strategies, in which we have covered the roofing operations and rest material operations. And then we have completed the module number 4, which is all about the advanced finishing toolpaths and machining strategies. So we have applied all the machining or finishing strategies on our part, including the 5-axis machining and some complex machining, including the raster finishing operation, project finishing, profile finishing operation, and then 3D offset finishing operation. So all these finishing operation we have discussed in the 4th module, and then we move forward for the 5-axis machining, which one is the advanced machining strategies in the PowerMill, including the blade area clearance and some machining area clearance operations. Then we have discussed about the toolpath simulation and advanced simulation, how to perform the simulation of the toolpath using the Autodesk PowerMill. Then also we have discussed about the verification and output, how that code is going to be generated, how the program is going to be created, and then how we just use that program for the machine. We have also checked that how the toolpath is now going to enter into the toolpath, and we have checked the gauges and gauges as well, that the toolpath is not going to touch down with the workpiece or any fixture which is being placed within that area. So everything which we have discussed till up to module number 7 is all about the Autodesk PowerMill. So in the 8th module is all about the final project. We are going to check your knowledge. We are going to discuss all the operations which we have started from the module number 2 to module number 7. So let's get started. So over here we have a part which is called the mold underscore core, and that part consists of mostly the object, mostly 2D, 3D, and 5-axis multi-axis operations. So what we are going to do is, this is the mold part, and it's a complex part, so we have to apply certain strategies to complete that part. So make sure that most of the parts which are being created in the industries, like big or large scale industries, for example, the mold industry consists of very complex parts. So that complex parts need to be machined using the multi-axis operations and some 3D toolpath strategies. So this is the example, and we are going to perform this example by performing the machining strategy operations on it. So what we have task over here, we just go and import the file, which is mold underscore core.dgk file in the Autodesk PowerMill. Then we'll go for creating multiple toolpath strategies to finish this part to ensure that the part is going to be finished mode. Then we are going to use the different tool size to make the surface more finished and more smooth. We'll create the individual file and the toolpath strategies to apply on the given path. And that's all the things which we have to discuss in this module number 8, which is the final project. So let's get started. So here you can see that I have already opened the Autodesk PowerMill. Now it's time to load the file. You can just go and click on the import option and just go to the examples. Over here, you will find out a file which is mold underscore .dgk. So let's go and find out the file, and that's over here. It's mold underscore core.dgk file. So just go and click open it. So you will find out that the part is being loaded into the software, and this is how the part is going to be looks like. So you can see that there are some different tapers, some inclined surfaces, some radius for the surfaces we have. And then we have a very special type of surface over here. You can see that this is the surface which is cannot be created by using the 3D, but most of the material can be removed from the 3D toolpath operation. But The real thing is that the tool is not going to be anchored in a vertical position. The tool has to enter in a different taper angle position. So this needs to be completed using the 5-axis operation. Some toolpath lead in. So we'll discuss by today. So let's get started and create this part. So the first part, you know that what we have to do is we have to create the block. So and just go and click on the block and click on calculate to calculate the block. So here you can see that the block has been created and it's all the way according to the size which is being given to the model. So as the model has a total length of around 95, then we have y-axis 90, then we have the total depth or total height of the block is going to be 25.39, so on. Okay, just go and click accept, but we have to make some changes because we want to make some addition material so that the part is going to be clamped, the part is going to be finished, and some facing operation we have to left some material on the upside. So let's go and create a work plane setup. So I'll just go and create on the work plane, right click, create work plane, or just go and use the create and orientate work plane using the block. So after clicking on that thing, you have to click on the center. This way the reference or the work coordinate system is going to be the center of the block. And what you have to do is just right click, rename it. What I'm going to do is I'll write it W1 for the work plane 1, and then I'll go in for activate it. So you see that if I just go and activate the block position is going to be changed, and we have to relocate our block and add some material to the block as well. So just go and click on the block and again click on the calculate button to calculate the block size according to the work position you have selected. But right now, as I told you that we have to place some material on the upside. So let me say that if I just go and lock that thing and add some material which is 2.0 millimeters in the upward direction, you can see that more amount of material is being added to this top. So that's 2 millimeters in the above side, all the way the depth is going to be over here. So you see that the depth over here is going to be reduced. So if you just go and unlock that thing, click again, calculate, and add some 2.0 material on the other side, that is going to be added to your stock. So the total stock is not going to be 25.39, it's going to be 27 because the total 2 millimeter stock is being added for the face operation. That is going to be same thing which if we are going to add some material like 20 millimeter on the y-axis, then we are going to add 20 millimeter on the x-axis. So that material is going to be used for the clamping purpose or some addition. So just go and click accept and that's it. So this is how the work coordinate system we have applied. Then we have applied the block or stock material to the model. Now it's time to apply some toolpath strategies, and the first toolpath strategy which we are going to apply on it is going to be the facing operation. So let's go and click on the toolpath and you will find out the curve machining, and in the curve machining we have to use a face milling operation because we have to move a stock from the top side, and that's 2 millimeter. So for this operation, we're going to use the 2D milling operation. So we'll go for one by one from simple operations to complex operation like 2D operations, then 3D operation, then finishing operations. Then we'll go for the multi-axis operation, and the final touch is going to be given. So just go and give the face milling operation, face milling. We'll just write the name, just click on the tool, select the tool. You can select the face mill tool as well, but here we have a combined stock of the end mill, which is being given over here. So just go and select the end mill operation or end mill tool and write the name of the end mill. I'll just use a end mill with a size of 30 millimeters, and then say that face mill tool. Okay, or face milling tool. So just write the diameter is going to be 30. The length is going to be 150. Let's make it 80 millimeters in length. So that's it. Number of units is going to be the 8. So let's go and click on the face milling, and we have to tell the maximum phase about where we have to perform the operation. So you see that the phase is going to be this one. This is going to be the Z0 position. So that's why what we have to do is we have to ensure that the phase is going to be Z. That's it. And the tolerance is being given as 0.01. So we'll make it 0.01 tolerance, not the 0.1 tolerance. Then we have to set the two-way passes, because in the two-way, the cutting tool is going to perform the operation in zigzag position, or the two-way cutting operation is going to perform. So let's go and set the step over. You have the step over distance according to the tool which you are going to use. So right now we're going to use the 30 millimeter face mill tool. So we'll set as 12 millimeter of this step. Okay, so now just go for the cut distance. So you will find out the depth of this top is going to be 2 millimeters. As we have to move the 2 millimeters depth of material, and the step down is going to be 1. So that's why it's going to take a 1 millimeter depth of cut with the 2 cuts is going to be performed. So let me calculate it and show you how it's going to perform. So you can see that the total material is the 2 millimeters and the depth of cut is going to be 1 millimeter. So in 2 depth of cuts, the material is going to be moved from the top, and you can see that it's going to perform the operation in this way. So we have to set up some feeds, leads, and rapid stroke. So click on the rapid movement and go and select the work plane which we have right now and calculate it. Then what I have to do is just go to lead and links and tell the tool that it should follow the straight position or the right way. That's the straight way, straight, and make it scheme. So if you just go and select this one, you can see that this is how the tool is going to perform the operation. So let's go and select the feeds and speed over here. I'll just go and set the speed with the 35 or 100 RPM for the spindle RPM. And the feed rate is going to be 1500 and the plunge rate of 300. So for the facing operation, we'll just don't need to set the coolant, because the material which is being used right now for this operation is considered as aluminum. So aluminum is a soft material. This doesn't need any type of coolant as well. So just go and calculate it, and this is how the first operation is going to be performed on Autodesk Power. So let's go and simulate it. So click on play button and you will find out that this is how the toolpath is going to be perform its operation. So from the center to over here, you can see that the toolpath is going to be applied. And that's the facing operation. So it's going to take multiple way to perform the operation, and it's completed. So this is how the first operation is going to be performed. And now what we have to do is we have to create another operation, which is for the proofing operation. So what we are going to perform is we have the facing operation done. We have to perform the roughing operation. We have to move a lot of material from that thing. So for the roughing operation, we'll just go and move forward for the model area clearance. That's the famous tool path for moving the lot of stock material from the model. So let's go and click on the tool path and go to the operation which is called the 3D clearance or 3D area clearance and find out the model area clearance. So that's the model area clearance for the roofing operation. Let's go and click on OK. So I'll write the name model area clearance. Now we have to set the tool as well. The face tool is not going to remove the material from this top. So let's go and set the another tool with a diameter of 10 millimeters flat end mill, because the flat end mill tool is used for mostly for roofing operations. So set the diameter 10 millimeter and make the length 100 millimeters. So here we have the flutes with the number of flutes is going to be 4. Then we have to consider to move the material all the way, which is being covered. So let's go and click on the model area clearance, set the offset value as a offset on, then set the tolerance value, which is close 1, set the thickness with the 0.5. That's the material is going to be, let's make it 0.2. That is going to be saved on this top, and the material is not going to be removed, although that material is going to be removed from the rest operation or the finishing operation. So let's go and set up the step over distance. The step over distance is not going to be the 12, but the step over distance is going to be the 50% of the tool. So we'll go ahead and set up as 5, make the step down value of, let's consider that we're going to step down the value of 0.5 millimeter. So that's going to be step over. So we want to move a lot of material from this top. So I'll just go, okay, offset, that's it. Everything is okay. So let's go to lead and links, go to links, make it straight, make it scale. Just uncheck the gauge. Then go to the feed and speed, make the spindle RPM of 9500. Fitting feed rate, one rate is going to be 400. Make the coolant on. Because the lot of material is going to be removed from the stock, so therefore we have to set these are the parameters for the cutting operation. So just go and click on calculate. See. But you can see that the operation has been applied to all the stock and it will remove the material. That is for the roofing operation. Okay, so you can see that wherever the stock is being placed, the cutting tool is going to remove that stock from the material. So that is for the roofing operation. Now it's time for the operation, which is going to be the model rest area clearance. So that's the third operation which we are going to apply on it. So just go and select the model rest area clearance over here. You will find out this operation, the model area clearance. So the rest material which we have right now, we're going to remove that. Okay. So rest model area clearance. So just go and set up the tool, and it's not going to be use the 10 millimeter tool, it's just going in or the smaller one, which is 5 mm flat end mill. We'll set it at 70. Here we'll just go and set up the thickness value of 0.0. Step over is going to be 2. Step down distance is going to be 0.1. So it will automatically detect the material. We have to set up the rest. We have to give the toolpath where we have set up the rest material. So this is the model area clearance. Everything is going to be the same. Make it straight, straight and skip, spindle RPM, feet weight, everything is going to be same. Make the 400 and click on calculate and so the toolpath is going to calculate the distance where the rest material is being over here, and it's going to cut down the material from all the way from the stock. So here you can find out these are the stock material, or the stock is being placed. So that's why he's just move on and remove the material from the stock here. So this is what we are going to perform the operation. That's it. So let's go for the other operations to be performed. So here we have to perform some fine operations over here. You can see that this is the thing which we have to apply over here. So a lot of materials being placed over in. So we'll just go and move the material from this thing. So the toolpath is not going to be approached within that area. So what we are going to do is we have to create certain amount of tool value. So you can just go and calculate the distance as well. So if you just go and click on measure, and what you are going to measure is going to the 3-point measurement. So if I just click over here, and if I just click here, you can find out the diameter is going to be the 4.445 millimeters. So within that 4.45 millimeters, we have to move some material over here. So the diameter should be the diameter of the cutting tool should be less than that thing. So that's why here we can just move that stock. So let's go ahead, remove that stock using the cutting tool. So I'll just go and use another toolpath, which is the model area clearance again, and be using the offset model. Then what I have to do is we'll write it for circular holes. Okay, and we'll use the limit option because we limitize our operation up to this value. So therefore, I just go and select the boundary operation and I'll write it P1. Use the composite curve to select that thing because I want to work within that boundary. Accept it. I'll go and select the tool. That is going to be, let's get 2.5 mm flat and mill. The size is going to be 50. Okay. So just go, we have selected the position, which is going to be the inside, and selected the step over distance of 0.5, set the step down 0.1, and just go and apply the operation. So you can see that the operation has been applied within that thing, and the stock is going to be removed. So what we have to ensure that let's say over here that the depth is not going to be taken inside. So we have to consider that the tool which we have made it is not going to be just tool set it at 2.5. So I think we should have to make this tool with a smaller in size. So let's go and delete this toolpath and make another toolpath over here. Model area clearance. And let's say that we can use a tool with a diameter of 1.5. So that is going to be help a lot. circular tool operation. The limit is going to be set it again. That's going to be B1. So over here, you can see that the toolpath is going to be moved in the downward direction. You can also set the limits over here. So if you just go and select the limit, and you can tell the tool that the tool is going to be started from the position, which is going to be 0. You can set it 0. And the minimum position is going to be the depth. So I'll just go for the depth over here. So you can see that the tool is going to be moved, look like that. Okay. So close it, and that's it. So this is the thing through which we are going to perform the operation on the upside. The one thing is more that we have to make a copy of this toolbar to the other side. So there is an option in the software, which is the toolpath transfer or toolpath transformation. So you can see that our workplace is set it at the center. So if we just say that the toolpath is going to be mirrored on the other side, that is going to be happen. So how you can just do it, you have to select the toolpath, right click over here, and you have to use the edit option. And in the edit option, you will find out the transform option on the upside. So click on the transform option, and you have to make a mirror. So when you just go and select the mirror option, a dialog box will be open. How about you have to make an mirror? So you can see that we have different axes over here. So if I just look at the top side, you can see that it's X and Y axis. Then we have X and Z axis. That is going to be happen according to X and Z axis. And then Y and Z axis, that is going to be this one in the Y direction. So we want to make the mirror about this position. So that is going to be the X and Z axis. So if I just go and click over here, so you can see that it's going to give you a preview that the operation is going to be performed over here. So just go and click OK. The transfer involves a mirror, so automatically pending behavior will not be applied. Just go OK. That's it. So you can see that the toolpath is going to be applied from this way to this way. So same thing is going to be happen over here when we are going to perform the operations on this side. So all these operations which we have created in up to right now is all the roughing operations, and we have to apply the finishing operations right now. So let's go and apply the finishing operation. So how we can just go and apply the finishing operation, you can just look at the toolpath and just go to the finishing operation over here, and we will find out the first operation is going to be the 3D offset finishing operation. That is going to be applied over here. That's the most famous operation. So if I just go and click OK, we have to apply the 3D offset operation. 3D offset finishing. So the finishing is going to be applied not in single step. We will use finishing in multiple steps. As you see that we have created multiple steps to create the roughing operation. Now it's time to apply the finishing toolpath in multiple way. So first of all, select the tool. So for the finishing operation, as you know that we have to use the bond nose and mill, bond nose mill. So we'll set as the tool with the diameter of 8 millimeters. BN stands for bond nose, and that's going to be 8 mm. It's going to be 18 millimeters. So just go and select the offset, and for the offset, what you have to do is you have to select the geometric pattern. You have to create or use a curve editor. So for the curve editor, I just use a curve and select the method to which the toolpath is going to be created according to the geometry. So I just pick up the outer boundary, this one, and say that according to this outer boundary, the pattern of the operation is going to be performed. So accept it. That's it. So set the step over distance, which is 0.1. And if you want to limitize the operation, so you can also use the P1 operation, or you can just go and create another and say that P2 and set that this is the limited operation. Within any side of this boundary, the toolpath has to make the finishing operation. So that's it. And set the minimum and maximum limits to check this disable, because we don't want our tool to be work within that limit. So we just have changed the limits. So let's go back to the 3D offset. Here we have set up the 0.0 or 0.1, but let's make it 0.3, because for the smaller tool, we'll just go and change the step over distance. So go to the rapid movements. Everything is being used with the work plane. Go to the legs. Let's CAM, make it straight. CAM. Set the spindle RPM with the higher rate, like 15,000. Bit rate is going to be 1500. So use the coolant as well for finishing. You can see that the toolpath is going to be applied over here, and with the distance of 0.3. Okay, 0.3 step. So this is the finishing toolpath which we have applied over here, and the part is going to be look smooth. But right now we have to create another toolpath so that the smaller increments will be set over here. That is going to be removed. So for that purpose, you can just go and use another toolpath, which is the raster toolpath. Okay, so raster finishing toolpath, we are going to use it. And right click raster, initiate. Set the limits as well, and set the tool with a smaller diameter of 5 mm bond holes. Okay. So that's going to be two-way. Yes, make the stamp over distance of 0.15. The ordering is going to be the two-way. Other value is going to be the same. Just go and calculate it. So you can see that this is how the toolpath is going to be applied over here. So just go and close it. So this is the smoothest way to perform the operation as well. So let's go and apply the operation on these circles or these two rows we have right now. So you know that for creating these operations, we have to use a very small amount of tool. So Let's go and click on the toolpath and apply the constant Z value, because over here we have to apply. So we have to ensure that the tool which is being used for creating the operation over here is going to be very small, because the tool has to reach to this point. So the tool is not going to be 5 millimeter or 2 millimeter. Now the tool is going to be 0.8 millimeter, and that is going to be the ball nose BN or PN 0.8, and the length is going to be 50. So limitize the operation, because what we are going to perform is going to make the inside operation. So just go and click on the constant Z operation, make the step down value of 0.1 and calculate it. So we have to see where the operation is going to be performed. So let's click on constant Z finishing. So I think we should have to create another, let's say that P3, select this P, accept it, calculate it. So you can see that the operation is going to be performed over here. Let's say that the step down is going to be 0.05, so that the operation looks smooth and clear. Now what you have to do is make a copy of that toolpath over here. The same procedure is going to be applied. Click on the edit, go to the transform, and make a mirror. So about X and Z axis. Okay. So this is how the toolpath operations we are going to perform it. So let's go and apply the operation over this side, because we have to ensure that the toolpath for this operation is going to be look like, because we have performed the roughing operation, we have performed the finishing operation, but the straw over here is not going to be removed, because the tool angle or the approach of the tool is not going to be happen over here. So what we have to do is we have to create a certain type of toolpath, or we have to set up a certain technique so that the tool may approach over this negative area and remove that material. Otherwise, the tool is not going to remove that material. So the purpose is to remove this area, and that is going to be happen using the special technique which is called the multi-axis technique. So how we can just go and apply the multi technique? So let's discuss today. So you can see that this is the curve over here. We can just go and create a curve over here. So for example, I'll say that I'll just go and create a pattern. So we have multiple ways to create the patterns as well. So I just go to curve editor, select this curve. So this is the curve I have selected. Also, I just go and make a boundary in such a way that this boundary is going to be the copy of that thing. Accept it. We'll just go and create a boundary. Make the boundary be 4. Select this thing. And make the offset with a distance of 0.5. Create a composite curve again. Okay. We just go back. Make it offset. So you can see that the offset is being created. I think we should have to make a more offset of 0.5. Okay. Accept it. Or I just go and select this thing, boundary. Go to curve editor. I think we should have to apply this thing on the surface as well. Or make it flatten. So this means that the boundary is going to be created on the upside. Accept it. Okay. Now, I'll just go and select the toolpath, but I should have to check it that boundaries should be within the range. So let's go and select the toolpath. I'll be using the constant Z toolpath for this operation because I performed the operation over here. Multi-axis. Then I have to use the boundary which is V4, keep inside. Use a tool. By using the tool which is 0.4 millimeter bar nose, by using the constant Z finishing, I'll be using the tool axis. Right now the tool axis being vertical, but the thing over here that we have to use a lead position. So if I just go and calculate it, you can find out that the tool is going to be, see how the tool is going to be needed and is going to perform the operation over here. So for example, the tool is going to be entered in a different way to create the operation over here, like that. And it's going to remove the material. So let me simulate this thing. So you can see that this is how the tool is going to be entered and it's going to cut down the workpiece according to the model. But the thing is that the tool is being reaching at certain angle, and that is not being applicable over here because what is going to be happen? The tool is going to be collide with the workpiece. So we have to ensure that the tool is going to be entered in a such way that it will reaches to the end of the workpiece, and as well as it's not going to be touched on the workpiece. So what we have to do is we have to set some settings which is related to the tool axis, and that is going to be the lead or lead. So we can set up the lead that the tool has to be reached at the angle of a certain degree angle. So for example, I've set it 45. You can see that the tool has only to be reached at 45 degree, and it's going to cut down the material. But certain area is not going to be performed. But there is another method which is called the vertical position. So in this vertical position, the tool is going to be only at 45 degree, and it's going to cut down the material. But it will never reach to the certain degree angle. So you can see it over here. Multi-axis. So you can see that it's at an angle of 45 degree leading E. And you can see that this is the way which is normal to the surface and taking only the fixed angle of 45 degree to remove the material. So we just go and slow it down. You can see that the tool is at only the 45 degree. And it's going to not making the right way to cut down the material. So what we have to do is we have to make certain values so that the tool should not collide with the workpiece. That is going to be the PowerMill 2012. Or we can use the 0. We can say that the lane is going to be 45. Or we have more options over here, like the curve we have. So we have created a curve over here. So that is not being calculated towards the curve. Let's see that. Okay. That is happening. So click OK and see how the operation is going to be performed. So just follow the curve over here. And that's the real thing through which the cutting tool is going to perform an operation and remove the material at 45. So this is how the operation is going to perform. So that is most compatible with the multi-axis. And through the tool axis position, we can just control that thing. So we have to create that thing on the other side as well. So the same procedure is going to be happen. Just go and click on the edit, go to transform, and use the mirror operation. Select the X and Z, and that is going to be happen on this side. Click finish, OK. And you can find out both the operations going to be performed. So you can see that this is going to be performed on the other side as well. So that's it for the finishing operation for the multi-axis. So you can just go and check these all operations, how the operation is going to be performed. And this makes the working operation, perfect and fine. We have to use the different types of tools over here. And in the last, what you have to do is you have to use a control operation to remove that material from the outside and make that part usable for further operations like buffing and other operations. So if I just disable it, you can see that this is the right way to perform the operation. Now, what you have to do is you will have to create some NC program over here. So right click and create an NC program. I will start as mold underscore core, the name of that thing. Just save this file somewhere else where you want to make it. So it's on the desktop. Make it mold underscore code. Save it. You have to select the machine file. You have to tell the machine which you have going to be used. So Fanuc we are being using right now. That's a generic file. So if I just have to use the Fanuc operation, just go and select this one and accept it. But we have to ensure that the operations, we have some multi-axis operations. So for the multi-axis operation, we should have all these operations to be made for 5-axis post processor. Otherwise, it will be difficult to make the 5-axis operation, because we have a file which consists of only 3 axes, but the operations which we have used contain some 5 axes. So the 5 for the post processor, you have it. You have to make sure that this should be added to the 5-axis operation or 5-axis post processor. So I have just sent these all files to the mold underscore core. You can see that these are the NC program, and that NC program is going to be used for the machine as well. What we have to do is just go and right click. So that's the final project for the PowerMill, including all the 2D operations, including the 3D operations, including the rest material operation, including the finishing operations. And in the last, we have applied the multi-axis operation. So I just go and save this file, do some practice on that thing. So that's the final project. You can save this file for future use. So I hope so that you understand how we can just go and create programs. You can see that we have applied multiple programs and multiple strategies to make this part. There are more ways to create this part as well. This doesn't mean that we have this way to create this part, but there are more ways as well to create this part as well. You can create a different groups to create the toolpaths. Like first of all, you can just go and create the group for the roughing operations. You can just go and create the operation for finishing operations as well. So that's it for the final project. Hope you understand how we can just go and create the part for that thing. So that's it for the final project. Thank you very much.